Hello everyone, welcome back to my channel once again. So last time we finished our video with question number 30 and we are doing class 11th chapter 1 exercises we are doing, and today we are going to do 31st question. So let's start. How many significant figures should be present in the answer of the following calculations? So what we have to do is we have to calculate it. Okay, without calculating it also we can answer it. Okay, there is a trick. So what we have to do is we have to take that which one is the least precise term over here. The least precise term over here after decimal is this one, okay, which has 3 non-zero digits. So it is going to have 3 significant figures. Okay, now if we go to the second question, the least precise digit is 5, but we can leave the 5 because is it exact number. So what we are going to do, we are going to take the number with the decimal, which is the other one, and it has 1 2 3 4 significant figures. So whenever we are going to calculate it is going to have 4 significant figures. Next one is an addition question in which we have to add. Okay, so there you can see that how many decimal places are there. So there is 1 2 3 4, and it is in the next question is also 1 2 3 4, in the next word also 1 2 3 4. So there are 3. Okay, whenever we are looking at the numbers there are 4 decimals, right? So its significant figures are also going to be 4. Now over here you can see this number has all the non-zero digits in the 4 decimal points. So obviously it's going to have 4 significant figures. Or you can do the other way also, you can calculate it and then you can get the significant figures also. Okay, let's do the next question, which is 32nd question. Use the data given in the following table to calculate the molar mass of naturally occurring argon isotope. So argon isotopes occurs in these 3 isotopes, which is argon 36, 38 and 40. These are naturally occurring isotopes. Okay, and their isotopic molar masses have been given and their percentage abundance is also given. Okay, let's take abundance as A. All right, and let's take isotopal molar mass as small m. All right, so the average molar mass of these all the isotopes will be molar mass will be summation of all the molar masses, right, multiplied by their percentage abundance. I is a factor that can be, that represents that isotopes can be 1 2 3 4 5, that is number of the isotopes. Okay, let's calculate. 0.337% means divided by 100, okay, multiplied by its isotopic molar mass, which is 35.96755, plus second one is 0.063 divided by 100 multiplied by 37.96272, plus the third isotope, which is 99.600 divided by 100 multiplied by 39.9624. okay, when we are calculating it, it comes out to be 39.948 gram mole inverse. So this is the average molar mass of argon, molar mass of argon, which is naturally occurring argon. So whenever argon is given to you, so maybe that argon will have these kind of all the isotopes in that, so its mass will be 39.948 gram per mole. Okay, let's do 33rd question, which is calculate the number of atoms in each of the following. So we have to calculate the number of atoms in each. Okay, so we know that 1 mole of anything is going to have 6.022 into 10 raised to power 23 atoms of that particular thing or molecules of that particular thing, right? So over here we have taken only atoms, argon, helium. Okay, so we are going to calculate for it, right? So for first one, we have been given 52 moles of argon. So it's obviously that this Avogadro's number is going to be multiplied by 52, which is 52 multiplied by 6022 into 10 raised to power 23. When we are going to multiply it, it comes out to be 3131 into 10 raised to power, because decimal is going to be way back after 3, so it is going to be 25. These are number of atoms of argon. Let's do the second question or second part of it, which is 52 units of helium. So this is given in the terms of a fewer atoms actually. As we know that 1 atom of helium weighs 4 unit. That means 4 unit of helium has 1 atom, right? 1 unit of helium will have 1 divided by 4 atom, and 52 units of helium will have 1 divided by 4 into 52. Okay, that is comes out to be 13 atoms. All right. Okay, let's do the third part, which is 52 grams of helium. Okay, so we know that 1 mole of helium is equal to 4 grams of helium, which has 6.022 into 10 raised to power 23 helium atoms. All right, 1 gram of helium will have 6.022 into 10 raised to power 23 divided by 4 helium atoms, and we have been given 52 grams of helium. 6.022 into 10 raised to power 23 divided by 4 multiplied by 52. So it is 13 actually. We have already done it, right? So when we multiply it, it comes out to be 78.286 into 10 raised to power 23. Decimal will be shifted, then 7.8286 into 10 raised to power 24 atoms of helium. So this is how the atoms of a particular substance are calculated. Okay, our next question is from empirical formula. So this question is, a welding fuel contains carbon and hydrogen only. Okay, you might have heard about it in the lower classes also, that which gas we are using or which hydrocarbon we are going to use in welding fuel. But anyhow, let's calculate for it. Burning of a small sample of it, we are going to burn it in the presence of oxygen, gives 3.38 grams of carbon dioxide and 0.690 grams of water and no other products, which means this fuel is only composed of carbon and hydrogen. Okay, a volume of 10 liter measured at STP of this welding gas is found to weigh 11.6 grams. So volume and mass relationship has been given, right? And we have to calculate empirical formula, mass of the gas and molecular formula. So let's do this question. Okay, first we have been given that how much amount of carbon dioxide is formed, right? Mass of carbon dioxide formed is given during combustion of this particular gas, which is 3.38 gram. All right, so we can calculate the amount of carbon from it. Okay, amount of carbon from 3.38 gram of carbon dioxide. Okay, we have to calculate it. How we are going to calculate? It is very simple. When suppose you have been given 1 carbon dioxide, it will have we can say 1 mole of carbon dioxide. Okay, it will have 12 gram carbon. Okay, 1 mole of carbon dioxide weighs 44 grams. So 44 grams carbon dioxide gives 12 gram carbon. Okay, so if 1 gram of carbon dioxide is given, then it becomes 12 divided by 44 grams carbon, and the amount is 3.38 gram. That will be 12 divided by 44 multiplied by 3.38. All right, in grams it comes out to be 0.9218 gram. Okay, now similarly we have been given water also, right? So the mass of water has been given, which is 0.690 gram, right? We know that 18 gram of water, which is 1 mole of water, it will have 2 gram hydrogen. So 1 gram of water will have 2 divided by 18 gram of hydrogen, and 0.690 gram of water will have 2 divided by 18 multiplied by 0.690 gram of hydrogen, which is 0.0767 gram. Now the amounts of hydrogen and carbon has been given. So that means the total mass of carbon and hydrogen, okay, in the compound. Okay, the compound is, you know that compound is only made up of carbon and hydrogen. So the masses, carbon was 0.9218 plus 0.0767, right? You add it, it becomes 0.9985 gram, right? So it is the mass of compound. The mass of compound is given now. So we can calculate the percentage of carbon or percentage of hydrogen. First we will calculate the percentage of carbon in the compound. How we are going to do that? We are going to take the mass of, given mass of carbon, which is 0.9218, divided by total mass of the compound, which is 0.9985, multiplied by 100. So that comes out to be, percentage comes out to be 92.32%. Similarly, we can calculate the percentage of hydrogen in the compound. We can directly we can use the same formula, or directly minus it from 100. Okay, we can do both. Let's do both. 0.0767 divided by 0.9985 multiplied by 100. It comes out to be 7.68%. Or what we can do, what I have told you, 100 percentage is going to be 100 gram of whole compound. If 100 gram of whole compound is taken, and from where carbon is subtracted, which is 92.32, when we minus it, its answer is once again that 7.68%. So you can use both the formulas for calculating the mass percentage of hydrogen. Okay, so we have been given mass percentage of hydrogen. You can do one more thing. You can draw one table like this, where elements are given. Okay, elements are carbon and hydrogen. Okay, first is going to be percentage by mass. Okay, we have been given this is 92.32 and this is 7.68. We know the molar mass or atomic mass. For carbon it is 12, for hydrogen it is 1. We can calculate the number of moles. Right, number of moles is given mass divided by molar mass. So over here also, when we are calculating it, it comes out to be, over here it comes out to be 7.69 and this is 7.68, which is approximately same, right? What we are going to do, we are going to calculate simple molar ratio. So how we do it? We take the number and divide it from the smallest number. Okay, the smallest number, both are almost same. So 7.69 divided by 7.68 is going to be approximately 1, and 7.69 it was 8 only, divided by 7.68 is going to be equal to 1. So simple molar ratio will be 1 and 1. Okay, that means if we are going to calculate the empirical formula is actually given as carbon ratio hydrogen. Their simplest molar ratios are written, that is 1:1, and it gives us empirical formula of CH. So we know one thing from here, that its molecular formula is going to have equal number of carbon and hydrogens. Okay, now we have to calculate the mass of the gas, molar mass of the gas actually. For that, what we are going to do, because that was the second question, mass of the gas. Okay, mass of the gas, this was the second question. So we have been given one thing, which is 10.0 liter of this gas at STP weighs 11.6 gram. Okay, fine. If 10 liters weighs this, then 1 liter of this is going to weigh 11.6 divided by 10. And we know that 1 mole of a gas is equal to, at STP it's going to be equal to 22.4 liter. So it is going to be 11.6 divided by 10 multiplied by 22.4. Okay, when we calculate it, it comes out to be 25.984 grams, which is approximately 26 grams. So what is 26 gram? 26 gram becomes molar mass of gas. Molar mass of gas is 26 gram. Okay, now the third question, in which we have to calculate molecular formula. Okay, to calculate the molecular formula, we must know the mass of empirical formula. Okay, So empirical formula mass is going to be equal to, it was CH, right? It was directly CH. So mass of carbon is going to be 12 plus mass of hydrogen is going to be 1, that is 13 unit. Now we have to calculate a factor which is to be multiplied with empirical formula N, which is equal to molecular mass or molar mass divided by empirical formula mass. So molecular mass was 26, empirical formula mass was 13. 13 twos are, so N is 2. Okay, so molecular formula is equal to N multiplied by empirical formula. So N is 2 and empirical formula is CH. So the molecular formula becomes C2H2 because 2 carbons and 2 hydrogens are there. And this is how you will calculate the molecular formula of a particular compound. Okay, the next question is question number 35. Calcium carbonate reacts with aqueous HCl to give CaCl2 and carbon dioxide according to the reaction. The reaction has been given. What mass of calcium carbonate is required to react completely with 25 milliliter of 0.75 molar HCl? So now this is a different question, and lot of question we have seen which comes out like this. Okay, so let's see how we are going to calculate it. We have to calculate it into 2 steps. So step number 1, okay, we have to calculate, okay, we have to calculate mass of HCl in 25 milliliter of 0.75 molar HCl. Okay, we have to calculate how much mass of the HCl has been used over here. So if we take that, if this particular volume was 1000 milliliter of 0.75 molar HCl, suppose, okay, it contained HCl, okay, it's had HCl 0.75 mole, okay, which is nothing but 0.75 multiplied by its molar mass. Molar mass of HCl is 36.5, okay, which comes out to be 24.375 grams. Okay, so if 1000 milliliter was taken, then it should be this much. If 1 milliliter was taken, then 24.375 divided by 1000, and at 25 milliliter as it is given in the question, then 24.375 divided by 1000 multiplied by 25. Okay, so 25 ones are 25, 25 fours are 100, and it becomes 40. And when we divide it, it comes out to be less than 1, obviously, 0.6844 grams. So this much gram of HCl was present in 25 milliliter of 0.75 molar HCl. Now let's go to step 2. Okay, step 2 is to calculate mass of calcium carbonate, because over here we have been asked mass of calcium carbonate, okay, that reacts with, that is reacting with, you can say, reacting with 0. 6844 gram of HCl. Okay, this much HCl will present. Let's see how much calcium chloride, calcium carbonate is reacting with it. So for that we are going to write down the complete reaction. Calcium carbonate plus 2HCl gives CaCl2 plus CO2 plus H2O. Alright. So over here from this particular reaction we get to know that 2 moles of HCl, that is 2 multiplied by 36.5 gram, which is going to be around 73 gram of HCl. It reacts completely with calcium carbonate, 1 mole calcium carbonate, which is, if we calculate the mass of calcium carbonate, right, 40 plus 12 plus 3 multiplied by 16, it comes out to be around 100 gram. Okay, so 73 gram of HCl reacts with 100 gram of calcium carbonate. So 1 gram of HCl will react 100 divided by 73 gram of calcium carbonate, and we have been given 0.6844 gram of HCl. So 100 divided by 73 multiplied by 0.6844, which is going to come 0.938 grams. So this is how you are going to calculate these kind of questions. Alright, our next question is, it is the last question also for the exercise, so let's do it. Chlorine is prepared in laboratory by treating manganese dioxide, MnO2, it is manganese 4 oxide, with aqueous hydrochloric acid according to the reaction. 4HCl reacts with 1 mole of manganese oxide, gives 2 water plus manganese dichloride and Cl2. How many grams of HCl reacts with 5 gram of manganese dioxide? So this is very easy. Okay, what we have to do, we have to see that 1 mole of manganese dioxide is actually reacting with 4 mole of HCl. Okay, 1 mole of manganese dioxide, so manganese is around 55, its mass is 55 and oxygen is 16, there are 2 oxygen, then 32. 55 plus 32 is 87 grams of manganese oxide. They are reacting with 4 moles of HCl, that is 4 multiplied by 36.5, which comes out to be around 146 gram of HCl. Okay, so 1 gram of manganese dioxide is going to react with 146 divided by 87 gram of HCl, and we have been given 5 gram, then 5 gram of HCl manganese dioxide is going to react with 146 divided by 87 multiplied by 5 gram of HCl, which comes out to be 8.40 gram. Okay, so that's all for today. We should be, very happy that we have completed our exercise of chapter 1. Now we are going to do few competitive based questions which have been asked in NEET or JEE in previous 2 to 5 years. Okay, NEET JEE exams from this chapter. So we are going to meet you all with those questions in the next video. Thank you so much. Have a nice day.